Okay, chapter 13.3, Quotient of Powers property. Okay, so this is the opposite of what we just learned in 13.2, product of powers property. So the quotient is obviously working with division. And here's a little bit of the key idea. Say you have 4 to the 5th power divided by 4 to the 3rd power. Now when we multiplied, we added. So when we divide, we're going to subtract. So this is going to be the same as 4 to the 5th minus 3 power, and that's going to equal 4 to the 2nd power. And this might seem like it's hard to remember, but it's really not too bad. Just remember to stretch it out again, just like we did before. You break it down and then you put it back together. So what happens if we just take 4 to the 5th power and we break it down? It's 4 times 4, 5 times. We multiply 4 times itself. And 4 to the 3rd power is just 4 times 4 times 4. Now you can see right away that 4 divided by 4 is 1, and 4 divided by 4 is 1, and 4 divided by 4 is 1, and that leaves us with 4 times 4, which is 4 to the 2nd power. So anytime there's a 4 on top and a 4 on the bottom, we can take one of those away. If there's more than one, we can take more than one. If there's 5 4s on top and 3 4s on the bottom, we can take 3 of them away, and that leaves us with 3 pairs. Since it's 4 times 4 times 4 times 4 over 4 times 4 times 4, you can take all the matching ones away. So it ends up being relatively easy. For the algebra side, you've got a to the m over a to the n. So to some number over to some other number, m and n are different, then you can subtract them, and it should come out looking like a to the m minus n. And this works great as long as a is not equal to 0. And they always say this whenever there's a fraction, because you cannot have 0, you can't have 2 over 0. 0 cannot be in the denominator, because 2 over 0 implies that 2 divided by 0 is something. And if this is true, if this is some number, then say n, then n times 0 would be equal to 2, and you can never do that. So it just doesn't work to have 0 in the denominator. Okay, so that's just that little something. Alright, examples. 2 to the 6th over 2 to the 4th is equal to 2 to the 6th minus 4, which is equal to 2 to the 2nd power, which ends up being 4. Okay. What about negative numbers? You might want to know. Here's a negative number to look at, negative 7 to the 9th power over negative 7. So it only works if you have the same base. The 2 is the base here, the negative 7 is the base. Negative 7 to the 3rd power. So we end up with negative 7 to the 9 minus 3, which is 6. Okay, and we could probably stop right there, or we could get out a calculator and solve it. It's going to be a positive number because it's negative 7 times negative 7 6 times. It's just going to work out. Alright, cool. Real quick, what if we did something like 3 to the 2nd power over 3 to the 1st power? That would be 3 to the 2 minus 1, which is 3 to the 1st power, which is just 3. Again, you can see that if you have 2 3's over 1 3, you're just left with 1 3. What happens if you have 3 to the 2nd over 3 to the 2nd? That equals 3 to the 2 minus 2, which is 3 to the 0, which is 1. And you can see that works here too, because if you have 2 over 2, it's 1. If you have pi over pi, it's 1. If you have 3 to the 2nd over 3 to the 2nd, it's 1. This is another example of why anything to the 0 power is always 1. Always good to see that. Alright, so here we go when we combine them. We got like 3 to the 4th times 3 to the 2nd over 3 to the 3rd. Now, first I might want to add them because I've got this product. This is from the last lesson. This ends up being 3 to the 6th over 3 to the 3rd. 4 plus 2 is 6. We kind of skipped that step again, and then we're going to skip the next step too. 6 minus 3 is 3, so it's going to be 3 to the 3rd power. We skipped this step where we did 3 to the 4 plus 2, and we skipped this step where we did 3 to the 6 minus 3. So, okay, very cool. See what else they have for us. One with some algebra letters. Working with letters. A to the 10th power over a to the 6th power times a to the 7th power over a to the 4th power. And again, you could just we could add first and then subtract, or we could subtract first and then add. Let's go ahead and we'll do this one. 10 minus 6, a to the 10 minus 6, and then this one, 7 minus 4, and then we'll come down here. 10 minus 6 is a to the 4th, and 10 minus 4 is a to the 3rd, and then when we combine those, it's a to the 4 plus 3, because this is a product, so it's a to the 7. And we could almost just say, well, there's a a to the, it works the same way if we add first. 10 plus 7 is a to the 17. 6 plus 4 is a to the 10. And then 17 take away 10 is a to the 7. And we still get the same answer. Alright, hopefully that's making sense. That's really all you have to do for this assignment, and it should be fun again.